grade 12s. Let's quickly have a look at question 2 of the March 2025 paper that was written by the learners of the Free State. Okay, so let's quickly get going with question 2, 2.1. Let's just get our highlighter ready. All right, so they say given the geometric series 8x squared minus 4x cubed plus 2x to the power of 4 plus, and then that continues on. All right, so those are the first 3 terms of my geometric series. So series is then because we are adding these terms together. Okay, so let's have a look at 2.1.1. So this is just the over here. The first thing that we actually have to start with, right, is the geometric series. Okay, so what you need to think about over here are your basic principles when you work with your geometric series. And it's basically what is the general formula or the formula for the general term of a geometric sequence. What is the formula for the sum of a geometric sequence? And then obviously we have to know about when a series converges. Okay, so those are all the formulas that we will basically need, given that they told us that this is a geometric series, guys. So don't just read over things. The word geometric series will give you a lot of tools to solve these 2 sub-questions of 2.1. So let's just go. I want to quickly show you something. We can see now a bit of exam technique. We can see that this question is number patterns, okay? So, or series and sequences. So let's go to the first thing that I would suggest that you do as soon as you see what the question is about is you go to your formula sheet, and to get your head in the mind space, in the toolbox, in the principles for the specific topic in mathematics, I suggest that you go to your formula sheet and you go and highlight all the different formulas, not just for a geometric series that we are going to be working with over here, but all your formulas and principles that are applicable to sequences and series. Okay, so quickly go to our formula sheet and let's do exactly that. So we know that for question 1, and I would advise you, right, to highlight everything in different colors. So for question 1, right, we actually use the quadratic formula. Okay, so we highlight that in yellow. So that is the quadratic formula, guys. And then just for interest's sake, right, you know that the discriminant, whatever is underneath the square root over here, the b squared minus 4ac, that is what you always use when you have to answer questions or to get the discriminant when you answer questions of nature of roots. Okay, so there that is. That's for question 1 type questions. Okay, guys, and please, this is just a guideline in most instances. Okay, I'm classifying it in this manner just to make it easier for you and to get your head ready for what tools I might need to use to answer these questions. Okay, but please know that certain questions may link certain topics, and then you can use these formulas in other questions as well. But this is just for you to remind yourself what options I have. Okay, I don't want you to use these in isolation, please. Okay, now we are going to highlight question 2's formulas, which are the formulas for number patterns and series. So this is obviously term n equals a plus n minus 1d. Okay, and that is the formula for the general term of an arithmetic sequence. And then term n equals AR to the power of n minus 1. That is the formula for the general term of a geometric sequence. Okay. Then we move on. Can you see they are quite nice to put the formulas across from one another? So this is, as we just said, the formula for the general term of an arithmetic sequence. And then right across from it is the formula for the sum of a arithmetic series. Okay, do you understand? So, and then the same thing with term n equals AR to the power of n minus 1. That is the formula for the general term of a geometric sequence. And right across from it is the sum of formula, or the sum 2 formula given to you to calculate the sum of a geometric series. Okay, and then obviously, guys, they say over here r is not equal to 1. Okay, and then, guys, r cannot be equal to 1 because then we will be dividing by 0 in this fraction, and then we know that that is not possible. Okay. So then the other reason why is R is our constant ratio. R is our constant ratio, and our constant ratio can actually not be 1, because if we multiply the previous term by 1, the next term won't change. So we won't have a pattern, okay, or a sequence or a series. All right. So that is why R cannot be 1. Okay, not that serious, guys. Okay, it's very important, but that's the reason why we state over here that R is cannot be equal to 1. Okay, then we move on to the last formula that we are going to be using on this specific formula sheet, and this is the sum to infinity, and that it's that we only calculate for the geometric sequence. So can you see that for the arithmetic sequence, it's across from one another, the formulas, and then for the geometric sequences, that is, or series, that is also all three the formulas are right across from one another. Okay, now I just want to add, guys, because I've seen in the past that this is converge. This part over here is what you use when they ask if a series converges or not. The fact that R, for a series to converge, a geometric series to converge, R has to be the value of R, the constant ratio has to be a value between -1 and 1. Okay, please, guys, you can get, when they ask converge, you can get the principle to use to solve these problems from your formula sheet. Okay, so can you see that now you have yourself in the right mind space and mindset to answer these questions? Okay, perfect. Now we can move on to answer some of these questions. All right, so let's go back. Now that we have, we've refreshed our mind with our options that we have, our tools that we have to solve these problems, let's get going. Okay, so they say, given the geometric series, okay, series, we just quickly went through the first three terms, 2.1.1, for which value or values of x will the series converge, guys, for 3 marks. So I just spoke about that on the formula sheet. Can you see that if you go to your formula sheet without even reading the questions, right, you already in your mindset, this is the portion that I need to use when they ask me about convergence. Okay, so let's quickly then, that's nice and easy. Always go to your formula sheet. I just showed you that. So I'm going to start by answering. So you will write 2.1 and then 2.1.1. Okay, so for which values of x will the series converge? Guys, I would suggest that you need a starting point, right? Because that's the most difficult thing in math, is where do I start? Sometimes I'm sure some of you feel that way. Where do I start? Now I'm showing you that before you start answering the questions, go to your formula sheet, highlight all the formulas that are applicable to number patterns or series and sequences. Okay. And then you saw the converge. So the first thing you do, they are asking about converge. So you write that principle down. So you say, okay, for a geometric series to converge, the constant ratio needs to be between -1 and +1. We get that from the formula sheet. Okay, do you understand? So you start, at least you have somewhere to start. And then once you have that, you go from there. So we know they are asking for values of x. Can you see for which values of x will the series converge? Can you see in the three terms that was given to us, they have x's inside. So guys, we are going to use that, and that is how we are going to incorporate x's into this principle over here, and then we will be able to solve for x using these inequalities. Okay. So let's get started then. So what we do, guys, is we use this basic principle, which is not on your formula sheet. Okay. So I would suggest that you have a separate, I always told my learners that for each unit, you need a separate page where you have your formulas and all of your principles. Okay. So this is the converge part is on the formula sheet, but to calculate R, your constant ratio, because we know R is definitely your constant ratio, right? It's your constant ratio. Okay, and how do we calculate the constant ratio, guys? This is a very important principle. That is, we say, okay, term 2 divided by term 1. Okay, that is how we get the constant ratio. And that should obviously be equal to term 3 divided by term 2. Okay, so that is very important, guys. Constant ratio, this is how it works. You take your second term, you take your second term divided by your first term, and you'll get your answer. And that is already your constant ratio. In this case, because they tell me it's a geometric series, so there will be a constant ratio. Okay, but I'm just these first term 2 divided by term 1 equals term 3 divided by term 2. That's very important. You will see later on as well that we are going to use this principle. So please, guys, note that this is extremely important. Okay, so now all you do is you just say, listen, we need to get a value for R. We need a constant ratio. And to get a constant ratio, we are going to have to put term 2 over term 1. Okay, so what is term 2? Term 2, guys, is it's not just 4x, please. It's not just 4x cubed. You have to take the sign with it, please. This is another mistake that you make. You only say 4x cubed, okay? And that's wrong. You have to take the sign for the specific term as well. So you have to take negative 4x cubed. So write negative 4x cubed. Okay, there you have that. That's term 2. Okay, so we have term 2, and then we have to divide that by term number 1, and term number 1 is then 8x squared. Okay, so that is term number 1, 8x squared. Okay, so can you see now we have replaced R with a fraction that contains x's, and they want us to solve x, so we are on the right track. Now we need to simplify to get the simplest version of my constant ratio, which is obviously going to be in terms of x. So for now, we are just going to leave that, okay? And then here in the middle, we are going to simplify. Can you see that 4 is half of 8, right? So 4 goes in itself once, and 4 goes into 8 twice. This is just the basics, guys, of simplifying fractions. Okay, so 4 goes in itself once, and 4 goes in 8 twice. So when we only look at the coefficients, of my numerator and my denominator, the answer is negative a half. Do you agree with me? Negative a half. Okay, perfect. Now we have to, and guys, this is grade 8 principles. So if you do not know this, I would suggest I already have a few grade 8 videos uploaded, and then it's please go and make sure that you revise your laws of exponents. Okay, so now, this is exponents, obviously, right? We have a base of x. Can you see in my numerator and also in my denominator, we have a base of x, and then we obviously have the two powers, cubed and squared. Okay, but remember, when we're working with fractions, you have to ask yourself, because we know we are dividing these two bases, right? And um, the law of exponent that says that when we divide bases, we subtract powers. Okay, so we know that we have to go and say x to the power of 3 less x to the power of 2, and that is obviously going to give me just x to the power of 1, which is x, right? But where do I write that x? Because I am working with a fraction. Okay, so it's always we taught you in grade 9 this specific part with the fractions, that you go and write it at your highest power, and your highest power of your base of x is in your numerator. So the x goes to the numerator. Okay, do you understand that? So now we have a simplified version. Now we can even make it more simple, and we can go and say negative 1. So negative 1x, we can just say negative x over 2. Okay. Okay, so there we have it in the simplest form. There is nothing else that we can do. It's actually better, guys. And this is also, these small things also confuse you. Okay, so we are working with one term. Okay, so you can actually move. Guys, it doesn't matter if the negative is over there, or let's just erase it first, or if the negative is over there, it doesn't matter as long as your whole term is negative. Okay, so you can move the negative around when you have one term to be right in the middle. Okay, that means the whole term is negative, so it's negative x over 2. Now, to get rid of our fraction, because we want x alone, they want values for x, right? So we need to isolate x, and to do that, we know that the principle when we work with fractions is that we have to multiply with our denominator to isolate x. Okay, and we are going to get rid of that negative as well. So we are going to go ahead and we are going to multiply by negative 2. Why? Because then that and that will cancel, and then we obviously have our x alone in the middle. Okay, do you understand that? Okay, but now we have to multiply on the right-hand side of this inequality with negative 2 as well. And on the left-hand side of this inequality, you also have to multiply by negative 2. Okay, so that is what we have to do. But now you have to remember, I just want to show you something, that um, let's talk about this principle first. Okay, so because we are multiplying with a negative number, our inequalities will change, will swap around, okay, to the opposite side of what it is. Okay, so that is very important. That principle that when I multiply or divide by a negative number, right? When I work with inequalities, my inequality will change, okay, to the opposite direction. Very, very important. So make a note of that as well, because you forget that in your test as well. Okay, so let's just do this, guys. I want to show you that you can leave your inequalities this way, but you can then just change your numbers around, because your smaller number should be on the left-hand side and your higher number or bigger or greater number should be on the right-hand side. Then you automatically correct um, the greater than and smaller than that changes because you divide by a negative. Okay, so let's have a look then. What is the answer of 1 on the right-hand side? What's the answer of 1 times negative 2? We know that that answer will give me negative 2, right? Okay. And then here on the left-hand side, negative 1 times negative 2, that will give me positive 2. Okay. So can you see that you cannot go and say, you just go and write the answers. You cannot go and say 2 and negative 2 over there, right, guys? Because that is not correct. Okay, so if you want to keep um, your inequalities exactly the way that they are, you would have to write your smaller number over here and your greater number over here. Okay, so, or just change your numbers around. So that is incorrect, guys. You have to then go and say, listen, my smaller number is negative 2. One is negative 2, right? So we have to write our negative 2 over there. And positive 2 is our greater number, so we have to write that over there. And then that is the correct answer. Now, I just quickly want to explain this to you to make sure that you understand. Okay, so let's just have a look. So it was originally over here, it was x should be greater than the answer that we have over here, which is 2, right? So x should be greater than 2. All right, but remember, it was originally, sorry, x should be smaller than 2 because of the sign change that we applied. So x should be smaller than positive 2. So x should be smaller than positive 2. Do you agree with me? Okay. We are looking at this over here. Okay. Over here, the left-hand side of this inequality, right? That what x is in the middle, the inequality changed to smaller than because we divided by multiplied by a negative, so it changed, and then the answer of negative 1 times negative 2 is 2. So can you see x should be smaller than 2? And when you write it like this, x should be smaller than 2. Can you see that that is exactly what we have in our answer on this end over here, is that x should be smaller than 2. Then on the other hand, when we go to the right-hand side, this part of the inequality, remember, because we multiplied with a negative, my inequality has to change to the other way around, right? So when you only look at the right-hand side, it should be that x is greater, right, than negative 2. X is greater than negative 2, okay? Can you see x should be greater than 1 times negative 2, which is negative 2, right? So this is what is true. And then when we go and look at our final answer, can you see that x is indeed greater than negative 2? Okay, so guys, this is just to answer any questions on why this still works as the answer. Okay, perfect. Now let's move to 2.1.2. Now, I just quickly want to tell you, I'm going to continue with saying or indicating what type of questions these are. So I would definitely say that this is a green question, guys, because you know where to start because you get the converge principle from the formula sheet, okay? And then from there, it's only substitution and then basically solving for x. And just remembering this very important principle over here, that when you multiply or divide by a negative, that your inequality will have to change around. But if you want to keep your inequalities, just put the smaller number on the left-hand side and the greater number on the right-hand side. Okay, perfect. And then just go and double check with these basics over here that we did. All right, and then it's this is just for yes. explanation purposes over there. All right, now, so this is a green one. So we expect 3 out of 3 for 2.1.1. Okay, then we get to 2.1.2. Determine the sum to infinity if x equals 3 over 2. So determine the sum to infinity if x equals 3 over 2. And this is for 2 marks, guys. So what you have to do over here is, can you see they give me a value for x, all right? That is very important. They give me a value for x. So now I can get the actual value of term 1, term 2, and term 3, okay? Because I can substitute 3 over 2 into the places of all of the x's, okay? Now they want me to determine the sum to infinity. Okay, so let's quickly go and do that. Once again, we just saw on the formula sheet that the sum to infinity, let's just go there. You can get that. We have our starting point. The sum to infinity, we can see, there it is. Okay, there is the formula for the sum to infinity. It's A over 1 minus R. Okay, so let's quickly go and apply that. So we once again, you will write your question number 2.1.2 and you will write your formula. Okay, the sum to infinity equals A over 1 minus R. Okay, so now we have to go and we have to substitute our values of x with 3 over 2. But please don't go and do everything, okay? Because we only need the value of a, right? We only need the value of a, and we know in series and sequences, a represents the first term. So that we have, right? Or that we need to get, okay? So let's quickly go and solve that. So to get a, we need to go and say, what was the first term? The first term was 8x squared. Okay, so 8x squared. So you will write 8. But remember now, in the place of x, we can substitute x with 3 over 2. You understand that? Because that's what they gave us over there. Okay, x is 3 over 2. So you substitute x with 3 over 2, and then it is squared. Okay, so what you do then, guys, is you can type this into your calculator and you can get your answer immediately. Okay, but I am not going to do that. I will explain that by first always applying your law of exponents, which says that your numerator and your denominator will get the square. So it's going to be 8. 3 squared would be 9, and 2 squared would be 4. Okay, so then your final answer is, this is 8 over 1, so we can cross simplify. So 4 goes in itself once, and 4 goes in 8 twice. And then when we multiply our numerators, we will get 2 times 9, which is 18. And our denominators would be 1 times 1, which is 1. So my answer for the first term is 18. Okay, so we can already go and substitute, and we can say, listen, we can substitute A with 18. We can go and write our 1 minus, and then we need to go and get the value for R, the constant ratio. Okay, guys, and we already worked with R, the simplified version of R, right? In question 2.1.1. Can you see that the simplified version of R that we got over here in this step over here is where we reached the simplified version of the constant ratio in terms of x, and that was minus x over 2. So can you see that R equals minus x over 2? Okay, can you see that? Now we have to just replace x with 3 over 2, okay? So we have to replace x with 3 over 2. So it's technically negative 3 over 2 divided by 2. Okay, you can put that in your calculator and get your answer. But then when we apply our rules for our fractions, guys, I do this the long way because you guys struggle to work with fractions. And when we get to trigonometry and all of those type of things, then you guys need to do this manually, and then you cannot do fractions. So that's why I'm showing this to you. So the principle over here is that you would say negative 3 over 2, which is your numerator, okay, you will, to divide the 3 over 2 by 2, you will have to change your division line into a multiply, and then you will have to do the reciprocal of the denominator. It's currently 2 over 1, so you will have to change it to 1 over 2 because we have to do the reciprocal when we divide. Okay, so then your final answer for R is when we only multiply our numerators and denominators, it would be negative 3 because 3 times 1 is 3, and then 2 times 2 in my denominator is 4. So my answer for R is negative 3 over 4. But remember, when we do substitution, please do it in brackets for me. We are replacing R with its value, which is negative 3 over 4. So you would say negative 3 over 4. Okay, and then that answer, the negative times the negative would give you a positive. So the simplified version of this is 18 over 1 plus 3/4. So it's 1 and 3/4. Okay. Then you type the simplified, guys, to avoid mistakes. Okay. You type the simplified version, 18 divided by 1 and 3/4 into your calculator. And then you would get a fraction of 72 over 2. So take your time and quickly put that into your calculator. See if you get 72 over 2. That you can leave as your final answer, or you can go and write it as a decimal, which is 10,29. Okay, so that is your answer for 2.1.2. Okay, then we get to 2.2. They say the second term of a quadratic number pattern is 13, guys. Quadratic number pattern. Okay, quadratic number pattern. They tell us that this is a quadratic number pattern. So all of the principles that and formulas that we know, we can use. Okay, so the basics that we know about a quadratic number pattern we can use. Okay, is 13. So the second term of a quadratic. So let's quickly do this together. So you know that there will be a first term. Okay, they tell us that the second term is 13. So stop. This is also what I recommend in math. Read a sentence, think about the principles of the specific words that they talk about, and then do what they tell you. So the second term is 13. So this is what we have. Okay, that's what we know from the first sentence. Okay, it's quadratic, and our second term is 13. Okay, there we have it. They say the general term of the first difference of the quadratic number pattern is given by term n equals 8n plus 2. So guys, that's the only information that they give. They do not give me any other terms in my quadratic number pattern. So basically, you will have to say we don't know the third term, we don't know the fourth term, and we don't know the fifth term, because you will see that 2.2.1, what they ask you is to get the first 5 terms of the quadratic number pattern. So it's this top part, 1, 2, 3, 4, 5. Okay, so that is what we need to get for the first 3 marks. Guys, sorry, let me just quickly go back. I forgot to mention that obviously 2.1.2 is also green. Okay, those are definitely things that you have to get correct, given that you know your principles. Okay, the general term of the first difference, guys, the general term of the first difference of the quadratic sequence or pattern is term n equals 8n plus 2. So these 3 marks, it's green. You should get it. I'm going to show you why. Or wait. No, let's not make it green. Let's make it yellow because it wasn't asked straightforward. So this is yellow. Okay, perfect. It wasn't asked straightforward. You had to think about what you know about your quadratic number pattern. So all you do, guys, in a case like this, we know that a quadratic number pattern has a first difference, which is the difference between that term, term 1 and term 2, the difference between term 2 and term 3, the difference between that, and the difference between that and that. So this we would call the first difference. Okay, this we would call the first difference. Do you agree with me? This line of answers over here. Then between these two, you would have a second difference. Okay, you would have a second difference and you would have a second difference. So can you see, guys, without any numbers, just apply what you know. And then your answer over here will be your second difference. Your answer would be your second difference. Okay, that is what we know. So now that we have the format to try and solve or to get the first 5 terms, we have to then use, they give us the formula for the general term of the first differences, which is term n equals 8n plus 2. So can you see that we can get this number over here, this first difference between 13 and the first term, we can get it because they give us the formula for the general term. So this is going to be the first term of my first differences of my linear pattern. By the way, this first difference will always be a linear linear pattern. Okay. An arithmetic pattern. Okay. So then we have to go and substitute our n's with 1 to get the first term of my linear pattern. Okay. So when we do that, we get 8 plus 2, which is 10. So can you see there, we used our general formula for our general term, or sorry, our formula for our general term of our linear pattern or arithmetic pattern, and then that gave me 10. Okay, so that is 10, guys. It's positive 10, so we plus 10, right? So from the first term to the second term, we added 10. Okay, so that means that the first term has to be 3. Let's use a different color. The first term has to be 3 because 3 plus 10 gives me 13. And now we can continue this by substituting the second term of my linear pattern, the third term of my linear pattern, and the fourth term of my linear pattern. So let's quickly do that. Okay, so term 2, let's just erase. Yes. Okay, so term 2 will be 8 times 2, which is 16, and 16 plus 2 will give me 18. So there we have our second term of our linear pattern, which is going to be 18. So plus 18. Okay, and then also we know that our second difference is a constant difference. Okay, it's your constant difference. So the difference between 10 and 18 is plus 8. So we add 8 the whole time to our linear or arithmetic pattern. Okay, so this is what we have to do. We plus 8 the whole time. We plus 8 the whole time. Why can we do this? Because they tell me it's a quadratic number pattern, and we know that these are the characteristics of a quadratic number pattern. So now we can continue. We can go and get this term, the third and fourth term of my linear number pattern. So 18 plus 8 will give me 26. Okay, so this will give me 26. And then 26 plus 8, that would give me 34. So can you see we are working this thing from the bottom to the top. And now we can fill in and we can get terms 3, 4, and 5. Okay, so what we do is we say 13 plus 18, that would give me 31. So there we have our third term is 31. And then we say 31 plus 26, and that would give me 57. And then we say 57 plus 34, and that would give me 91. Okay, so there we have 2.2.1. We have the answer for 2.2.1. Okay, because there we have the first 5 terms of the quadratic number pattern. So can you guys see that you just always start doing what you know about this pattern and then fill in all of the blanks, and then you would get to your answer. Okay, so let's then quickly do 2.2.2. So they say, hence, I'm going to change this because this is now going to be green. So they say, hence, determine the general term. Okay, determine the general term of your quadratic number pattern. Okay, so we know that we have our first 5. We have our quadratic number pattern. So this is very easy. This is, this is what you have to study. And it's usually your easy marks in your number pattern question. So the first thing that you need to do is we know that we have to get the general term in this form, an squared plus bn plus c. So we basically need to get a value for a value for b, and a value for c, because n needs to remain unknown. All right, so what we do then is we say 2a equals my second difference. So 2a equals my second difference. It's always the case, by the way, you can study it. It's always going to be 2a. So 2a equals my second difference of 8, okay? And then to solve a, we say a equals 4, okay, to isolate a. So that's nice and easy. And then the second step, which you can also always study, is you say 3a plus b equals the first of your first differences. So the first of your first differences. Can you see, guys? We go from the bottom to the top. Okay, the first of your first differences, which is going to be 10. Okay, now we solve for b, because we know that the value for a is 4, so we can substitute that, and then plus b equals 10. So 3 times 4 is 12, plus b equals 10. And then obviously when we take 12 to the other side, it would be negative 12. So my answer would be negative 2 for b. Okay, then lastly, the last portion, remember, all of these that I'm underlining is what you study. These are the steps. 2a equals your second difference. 3a plus b equals your first of your first differences. Okay? And then this last portion is where you say, this is also what you always can write down, term 1 equals a plus b plus c. Once again, this is what you can study off by heart, and then just write that down. So those are the 3 steps that you can use to solve A, B, and C. And then you just go and replace. So now we are term 1. You go and substitute. So term 1, you go and substitute term 1. What is term 1? Term 1 is 3. So you would say 3 equals, what's the value of A? That is 4. What's the value of B? That's negative 2. And we want the value of c. So that's very easy. So c would equal 4 minus 2 is 2. When we take over the 2, it would be negative 2. So that is then 1. So then we go and just put the values of a, b, and c into the formula for the general term. So therefore, it would be term n equals, in the place of a, we write 4n squared. Okay, b is negative, so it would be negative 2n, and then plus 1. And then we have our formula for the general term of my quadratic pattern. Okay. Okay, grade 12. Let's move on to question number 2.3. So given is the sequence 2, 3, 5, 6, 8, and 12. Now, the first thing that we do when a sequence is given to us, before even looking at what is required, is you have to go and figure out what type of sequence are we working with, right? We can either have a quadratic sequence or an arithmetic sequence or a geometric sequence or a mixture of the two, or okay, so we have a few options. So we always first have to check for whether or not the sequence is arithmetic, which means it has a constant difference. Let's quickly check that. So you would see that to get from 2 to 3, you say plus 1. To get from 3 to 5, you say plus 2. From 5 to 6, we add 1. From 6 to 8, we add 2. And then all of a sudden, from 8 to 12, we add 4. So we can clearly see that this is definitely not um, an arithmetic sequence because it does not have a constant ratio. So that is out. And then we move on. I'm just doing this the way that you would have tried this in the test because this is not a straightforward sequence that is given to you. And then you would have tried to look for R, a constant ratio, right? Because if we have a constant ratio, it's going to be a geometric sequence. But then when you take term number 2 and you divide it by term number 3, your constant ratio is 3 over 2. And that should be equal to term number 3, which is 5, divided by term number 2, which is 3. And can you see that you do not have a constant ratio? So this is also not a geometric sequence. Okay, so now we have to go and look. We had just looked at a quadratic sequence, and then if you would have looked, you know that for a quadratic sequence, we have a linear pattern, and then you would have seen also that the differences that we had just now when we checked for a constant difference is also not a linear sequence or a linear pattern. So it's also not going to be a quadratic sequence. So now we have to go and look at all of our other alternatives. And one other alternative that you always have to be on the lookout for is where there is a mixture of two sequences within one. Okay, so let me show you what I mean. So when we have a look at the first term, which is 2, and then we skip the second and we go to every second term, right? So it's the first term, the third term, and the fifth term. You would see that we have an arithmetic sequence with all of the green terms because can you see from 2 to 5, from 2 to 5, we add 3, okay? And then also from 5 to 8, we also add 3. So can you see there we have an arithmetic sequence with a constant difference. D, remember the constant difference, right? D represents the constant difference, and the constant difference would be 3. So can you see then that we have another sequence is every other number, all of the even terms, like term number 2, which is 3, term number 4, which is 6, and term number 6, which is 12. Can you see all the yellow terms, all the even terms? They have a constant ratio. Okay, let me have a look at that. Let's just use a different color then. So when we, to get from 3 to 6, yes, you would try to say, okay, it's plus 3. If you wanted to test for the constant difference first, but then when you check the difference between 6 and 12, you would have seen that the difference over there is 6. So then you already see that an arithmetic sequence is not possible. So therefore, you have to jump to your your geometric sequence, and then you would see that you multiply by 2. So 3 multiplied by 2 will give me 6, and 6 multiplied by 2 will give me 12. So there you see. So right, the green term, so this is a mixture of two sequences. Okay, so always be on the lookout if if there's no constant difference in the original sequence and there's no constant ratio and it's also not a quadratic sequence, then you have to go and check for this two sequences in one. Okay, so in the yellow sequence, we have a constant ratio, which is R, and that constant ratio is 2. We keep multiplying by 2. Okay, so now we have something that we can work with over here. Okay, so now we can start answering our questions. So let's go to 2.3.1 and quickly read the question together. So they say, determine the next two terms in the sequence for 2 marks. Okay, guys, this is nice and easy. So let's go ahead and highlight this. You should get um, these 2 marks, okay? Because this wasn't the most difficult. This is taught in the textbooks. So to be on the lookout for two sequences in one. So the following 2 terms should be easy then. So your next term, guys, is your next term is going to be a green term, okay? So it's going to be part of your arithmetic sequence, right? Where we add 3. So that means that 8 plus 3 would give me my my next term. So 8 plus 3 would give me 11, okay? All right, perfect. Let's highlight that green to show that it's part of it's part of the green sequence, okay? And now we need one more because they ask for the next 2 terms in the sequence, okay? So we have 1, which is 11, and then we need another one, and that is then going to be part of the yellow sequence, and that is the geometric sequence where we have a constant ratio of 2. So obviously then that means that we have to go ahead. Okay, there's no space over here. Or let's just do this. Let's just erase that constant ratio and write it over there that R equals 2. And then we have some space to get from 12 to our next one, which is where we also have to multiply by 2. And then 12 times 2 will then give me the 24. Okay, 24. Okay, so can you see those? That is then the next 2 terms, and that's then going to be part of the yellow sequence. So 24 is then going to be part of the yellow sequence. Okay, so can you see that the answers for 2.3.1 is then 11 and 24? So let's just go and write. Okay, question 2.3, and then we just did 2.3.1. And then we know that the following 2 terms is going to be 11 and then 24. And there you have 2 marks. Guys, that wasn't difficult, okay? I always suggest that you have to study math. And this is part of studying math because what is in your math textbook, this type of sequence will most definitely be in your math textbook. Okay, so please don't just work out past papers. Past papers, it's your last resort. It's always best to go cover all of your math principles in your textbook, and then you can come over to working out papers. All right, so then 2.3.2. Let's quickly read the question for 2.3.2. What we need to do there for 5 marks is they say you have to determine the sum of the first 39 terms. Okay, let's just highlight what we need to do over here. And this is definitely going to be a yellow sum. I'm going to explain that to you now, my reasoning behind that. So they say determine the sum, guys, of the first 39 terms. So the sum of the first 39 terms. So we know that we are going to be using the sum of formulas, right? Which we have highlighted at the beginning of this question. Okay, so the sum of formulas we have highlighted, we know what they are, we know where to get them, so we have a starting point. Okay, that's the most important with math. Okay, so let's go ahead and say determine the sum of the first 39 terms. Guys, now this is the reason why this is a yellow question, because they ask for 39 terms and not 40. Now, I want you to pay attention here because this was the only trick, okay? So if they would have asked for 40 terms, right, it would have been extremely easy, okay? Because remember, we have two sequences. We have two sequences mixed into one main sequence, okay? So to get to the 40th sequence, right, the 40th term, right, we would have had 20 terms of the green sequence, and we would have had 20 terms. We would have had 20 terms of the yellow sequence, and we also would have had 20 terms of the green sequence. Do you understand what I'm saying? To get to 40. Okay, so that is what you need to think about. Okay, we would have had 2020 if they asked us for the first 39 terms. So that then means that you would have done the sum to 20 of the arithmetic sequence and the sum to 20 of the geometric sequence. Do you understand? And then you would have added those answers together. Okay, so this is the best way that I can explain what is happening over here and where the catch is. But they thought, oh, that's going to be too easy. Let's rather ask 39 terms. Okay, so that then means that one term is going to have 20 terms, and the other, sorry, one sequence is going to have 20 terms, and the other sequence is going to have 19 terms because we haven't reached 40 yet. So one sequence will be missing one term to take it to 40. So that is what is difficult, right? One term will be summed to 20, so one sequence will be summed to 20, and the other sequence will be summed to 19 terms. Okay, now because it's 39, okay, so now we have to determine, will the green sequence, the arithmetic sequence, will that have reached 20 terms by the 39th term, or within 39 terms? And the answer is yes, because that is the sequence that we start with. Okay, so if you think of it as in pairs of two, right? First green, then yellow, first green, then yellow, first green, then yellow. Can you see that every even term, 2, 4, 6, so the 20th, the 40th term would have been a yellow term. Do you understand? The 40th term would have been a yellow term. And they are not asking us to, or for 40 terms, the sum to, or the sum of 40 terms. They are not asking us that. So basically, that last, remember, let's say this would then be the 39th term, right? And then we would say comma, and then the 40th term would have been, let me just get the green, the yellow. The 40th term would have been a yellow. Do you understand what I'm saying? So we have not reached 40. They're only ones up until 39. So that then means that yellow one got slashed. Okay. So we end at the green one. And that is why the green sequence would have reached 20 terms. Okay. And the yellow sequence will then only have 19 terms. Okay, do we understand that concept? So now let's just fix what we know now. So we know that of the green sequence, our n, let's do it all together. Our n is going to be 20, right, of our green sequence, and n is going to be 19 of our yellow sequence. N is going to be 19 of our yellow sequence. Okay, and as can you see, 20 terms plus 19 terms will get me to the sum of the first 39 terms. And now we can start with our calculations. And now it's nice and easy, okay? Because you just go to your formula sheet. The first thing that we are going to do is we are going to work with the arithmetic sequence, the green sequence with the constant difference, okay? And with our n, our number of terms is then going to be 20, okay, for that specific sequence. Now, when you go to your formula sheet, you would see that we highlighted already. Okay, so we know that this formula over here is the sum, the sum to n terms, or the sum of n terms of your arithmetic sequence. So this is the one that we are going to be using. The sum to n is n divided by 2 times 2a plus n minus 1 times d, and then that all in brackets. So you go and fetch it from there. It should actually be imprinted already in your memory, but if it's fine if you have to go to your formula sheet. So our starting point is then that we are going to say the sum to n is going to be, guys, write the formula. If you struggle with math, it's always best to go and write the formula as it is and then go and substitute everything. And obviously, those of you who are a bit more advanced with the maths, you go and replace that immediately. There's no problem with either way. Okay, so you then go say the sum of n terms is then n divided by 2. Okay, and then you write your bracket. That is then times 2a plus n minus 1 times d, and then you close your bracket. Okay, there's my formula. So let's just substitute everything. Okay, so let's then go and say we need to calculate the sum of the first 20 terms, right? So we have to go and replace n with 20. So we are going to say 20 divided by 2, okay, times, remember, what does A stand for? Guys, what does A stand for in the number patterns formulas? It stands for your first term always. Okay, so this always stands for your first term. Okay, and your first term is 2. Okay, your first term is 2. So you are going to say 2. Remember, when we substitute in brackets. So 2 times 2 plus, once again, n has to be replaced by 20. So it's 20 minus 1, and then, guys, it's times d. What is d? D is my constant difference. We add 3 to this arithmetic sequence, so d equals 3. So it's times 3, and then you close your bracket. Okay, I would suggest that you go and do the math that you can do, the simple math that you can quickly do. Go and do that, because it's always best to type in as less as possible in your calculator to avoid mistakes. So we know that 20 divided by 2 is 10. We know that 2 times 2 is 4. And then we know that 19 minus, sorry, I have the answer in my head already. 20 minus 1 is 19. We keep this in brackets. Why? Because we still have to multiply that by 3. Okay, close your bracket. And then you can type this simplified version in your calculator, and then you can get your answer of the sum of the first 20 terms, and that will then give you 610. Okay, so there you have a few marks in the bag already. Okay, so now let's just continue, have the sum of the first 20 terms right with it. Okay, so there's the answer for the sum of the first 20 for your arithmetic sequence. Okay, so now we need to deal with the sum of the first 19 terms of your geometric sequence. Okay, now let's go to our formula sheet. We know for a geometric sequence, the sum of the terms for a geometric sequence has a different formula. So we need to go and get that. And this is the formula that we are going to use. Can you see the sum to n, or the sum of the first n terms? And that's given to you as a times r to the power of n minus 1 over r to the power of 1. Okay, and guys, they just say that r cannot be equal to 1, obviously, because 1 minus 1 in my denominator in this formula, when we say 1 minus 1, that would that is impossible. That does not exist. Okay, so it will give you a math error on your calculator. Okay, that is why we have to say that this limitation applies to this fraction. Okay, that's all that that stands for, but you only use this part over here. Okay. Um, then we can just go in and write the formula from our formula sheet. Not that difficult, right? Okay, so we're going to write our formula. So the second thing that we need to do is number 2, is we need to go and write our formula for the yellow sequence, which is the geometric sequence. So we're going to say the sum to n equals, it's going to be a fraction formula. So it says that a times r to the power of n minus 1, right, in my numerator, divided by r minus 1. Okay, so there's my formula, and then I go and replace or substitute, right? So we know that for the geometric sequence, we have to only work with the first 19 terms. So we are going to say the sum of the first 19 terms of this sequence. So we will be replacing n with 19. Remember that a stands for or it represents the first term. So the first term of the yellow sequence we know is 3. Okay, so we know that it would be 3, and then you make your bracket. You replace r. What is r in your formula? R is your constant ratio, which we have written here above already. So remember that r equals 2. That is your constant ratio, what I multiply with. So we replace r with 2. We replace n once again with 19, and then minus 1. And then we divide by 2, which is the value of r, minus 1, guys, which is in any way going to give you 1. So we technically do not have a denominator. Okay, so you can just type in your numerator into your calculator, and you will have your answer. So when you do that, you will get the answer for the sum of the first 19 terms of your geometric sequence. And then that would be, you would get 1,572, 861. Okay, so can you see that now you have this separate answers, the sum of the first 20 terms of your arithmetic sequence, it gives me 610, and you also have the sum of the first 19. So what we need to do to answer the actual question of 39 terms is we need to go and we need to add these two together to get to the first 39. So you are going to say that to get to the sum of the first 39, you have to say the sum of 20 plus the sum of 19 of these two sequences, which is actually mixed into one, and therefore you would say 610 plus 1,572,861. Okay, and then when you add those two together, you would get your final answer, which is 1,573,471. Okay, so that is then your final answer for this question. Okay, so that was 5 marks, guys. I would, yeah, you would probably, if you made a mistake in 2.3.1, then you, yeah, let's work with, it's a yellow question. So I would expect about 2 out of 5 because of this little catch from most of the grade 12s. Okay, so let's move on. I would have forgiven you if you lost a few marks in that in the calculation of that 5 of that sum there. Okay, so let's move on to 2.4. Okay, so 2.4, and now this is where you have to focus because in my experience with my grade 12s, they always struggle with sigma notation. Always, always, always. And it's actually the principle of applying this is very, very simple. Okay, so now let's have a look at the question for 2.4. They say write the following series. Okay, so Series is just when we add the terms of a sequence together. So you would see pluses and minuses in between instead of just commas separating the terms. So this is a series. So they want us to write this series in sigma notation. So they want us to write the series in sigma notation. Guys, now let's just quickly remind ourselves, okay? Because I realize with my students as well, if they find something um, strange, okay, then or unfamiliar, then or difficult even, they skip that, okay, and they only focus on the things that are really easy to get them through the papers. But this is really easy, okay. So you guys think this is difficult, you guys think that this is something you can skip, but this will always be asked in your number patterns, in your sequences and series. So please, let's fix that now. Okay, so guys, this is as simple as this. To write a series in sigma notation, guys, sigma it's a Greek word meaning the sum of, okay? So you just add, it's as simple as this. You add every single term in your sequence. That is all that sigma notation means, okay? So we cannot write all of these terms next to our sigma notation and say this plus this plus this plus this, right? So what we need to do then is instead of writing the whole series, we go and get the formula for the general term. We have to write this simpler, okay? So we say, listen, we want to get the sum of all the terms of this general term from the first term to the nth term. And remember that terms, the number of terms, are elements of natural numbers. Okay, so let's start with that. That was a quick theoretical background. So let me just do this for you. So this is sigma. This is how you would draw it in your paper. Okay, so that is sigma, right? Okay. Now they we would start. They did not give me a limitation or whatever that we have to start adding up from the second term or whatever. So then you can go and write. If they don't say anything in terms of at which term we start, you go write k equals 1. Guys, that just means that in this sequence of terms that we are adding together, we are starting at the first term of the sequence, and that is then 64 over 5. Okay, that is what we say when we say k equals 1. Okay, and then can you say it says up to n terms? Okay, so what you do on the top of your sigma is you go and write up until what term do you want to add up to? Okay, so they want up until n terms. So if they want it up until n terms, you need to go and calculate, or you always need to calculate the general term when you do sigma notation, and you always need to have at least the first three terms when you work with sigma notation. So that's all given to you. So this is actually going to be part of your answer already. Okay, so what you do over here is you just go and get the formula for the general term of your sequence, guys, and that is literally as easy as that. Okay, so you write k equals 1 when you have to start adding up from your first term. Okay, they want you to add up. It says to n terms. They don't give you a specific number of terms to add up to, so it's going to be n. And then next to your sigma, you will have your formula for your general term of your formula. It's as easy as that. So guys, the only thing that you will have to calculate to write it in this in sigma notation is he will need to calculate or to get the answer of the formula for your general term, okay, of the sequence. So that is what we are going to do first. Okay, so you first need the formula for your general term. Okay, if you did not know that, guys, make notes of this. You first need the formula for your general term. Okay. So that is what we are going to start with. Okay, so before you even write your sigma, can actually go and do that. You can go and do this already, because you know that just means and. We are going to start adding up from the first term. They want us, it should be the nth term, and we know that over here, because we will have brackets, let's just make this a square bracket. Over here, you put in your general term, which we are going to be calculating now. Okay. So when you want to get your general term, guys, we know that we have to first have a look at what type of sequence this is. Okay, what type of series this is. Is it um, let's talk about a sequence because we are actually talking about the individual terms. So you have to see if this is an arithmetic sequence or if this is a geometric sequence. Okay, that's what we have to do first. Okay, it can be a quadratic one as well, but let's first test for the two simplest ones. Okay, so can you see that? And another thing that makes this, let's just tell you already, this is going to be a yellow question. Um, just because of the fact that it's fractions. Because if you see fractions, it's somehow you cannot do math when you see fractions. So let me help you with this one specifically. So when you look at your, I would always suggest that you look at or you just use your calculator, guys. Let's just stick to that. Okay. So when you see that um, your signs are changing, right? When you look at your next term, like the first term is positive, the next one is negative, then it is positive again, then it is negative, and then it's positive, right? Okay, so that then means that you are multiplying by a negative number, okay? Because when you multiply with a negative number, then you know that your sign is going to change the whole time. So we know that we are definitely multiplying with a negative. Now we have to find out that we are multiplying with negative what to get to the next term. Okay, so you can then go ahead and you can say, okay, to get to R, we know that this is going to be a geometric sequence then, or series then, because we are multiplying with something, right? Okay, then we know we are working with a geometric sequence, okay? And we know that the formula for that is term n is a times r to the power of n minus 1, okay? That is what that is, okay? But actually, remember now, we want it in terms of k, so let's make it easier for ourselves. I just wrote this from basically from what I know, but we are working here with term k, so let's just do it right from the beginning. So just replace n with k, okay, when you work with sigma notation, okay? Then you just go ahead and you say, to get your constant ratio, you always have to go say term 2 divided by term 1, okay? And what is term 2? Term 2 is 32 over 5, negative 32 over 5. So negative 32 over 5, and you divide that by 64 over 5, right? That's how we get our constant ratio. And then you would get that the answer for R is then going to be negative a half. Okay. So you would be multiplying by negative a half every time. Okay, so you know that the value of R, we are working with a geometric sequence, okay, because we saw that our signs are changing the whole time, okay. So yes, so that means we are multiplying with a negative. Okay, then we just had to get the value, and we just said term 2 divided by term 1 would actually give me the answer for what I'm multiplying with the whole time. So therefore, we can go and replace that. Now it's nice and easy. Once we have the value of R, our constant ratio, we can go ahead and we can say the first term is 64 divided by 5, right? Okay. And then we have to write our times, and then we have to go and replace the value of R, which is negative a half. Okay, and then that is to the power of k minus 1. Okay, and guys, you leave this exactly the way it is over here. Okay, can you see? Please, so many learners make the mistake of saying they then multiply the 64 over 5 with the minus a half, and then the answer of that is they raise to the power of k minus 1, and that is completely wrong, guys. So please never do that. You substitute a and you leave it in brackets. You substitute r and you leave it in brackets. You never multiply these two. That's principally incorrect. Okay, so or mathematically incorrect, because guys, only you are then changing the formula when you do that, because only, can you see in the formula, only r is raised to the power of k minus 1, not a, only r. Okay, so therefore you have to keep it separated, because only r needs to be raised to the power of k minus 1. So this is my final answer. Okay, now that we have our formula for the general term, term k, we can go and write it into our sigma notation. Okay, I'm going to have to expand this bracket because of all of the fractions that we are working with. So let's just expand the bracket a little bit, and then we can go and write that. You can just go and then say that your term k equals bracket 64 over 5, right? Close your bracket, times another bracket, negative a half, close your bracket, and that is to the power of k minus 1. Okay, can you see? This is how easy sigma notation is. Okay, the only thing that makes this a yellow question is the fact that we are working off. It shouldn't actually be, because you know, guys, yeah, you know that to get your constant ratio, you have to say term 2 divided by term 1. Okay, but yeah, this is the way to get to the answer. So fractions shouldn't actually throw you off when you work with your sequences and series, because you just follow your principles. And actually, we should have actually just said that that should be equal to term 3 divided by term 2, right? So if both term 2 divided by term 1 and term 3 divided by term 2, if both of them gives me, which they do, if both of them give me negative a half, then we know that it is a geometric sequence with the ratio of negative a half. Okay. So perfect. That is just what I need to add, what you have to remember for me. All right. So that is the answer, guys. That's the 3 marks. And then this is your final answer for your writing that series in sigma notation. All right. Let's move down to the last question of, or the last sub question of question number 2. Now, this, I am going to be honest with you, this is a pink question. So a pink question is one that I would expect, yes, most of you, or most learners, sorry, most learners to struggle with. Remember, they have to add these more difficult types of questions in here for the 80% or the 70% above type of learner, okay, to give them a challenge as well. So this is a more difficult question. It actually borders on yellow or pink, but let's make it pink. A pink means I would excuse my learners if they got 0 out of 6. Okay, so that is what pink means. All right. So let's continue with this. Let's just read what they say. They say the numbers 7, x, and y forms a geometric sequence, guys, a geometric sequence. So they tell me that these numbers 7, x, and y, it forms a geometric sequence. So we know that we can use the principles of a geometric sequence. Okay, so that is the first thing that we know that we are going to use, right, to solve this problem. Okay, what do we know about a geometric sequence, guys? Always just go to your basics, even before you continue reading. We have some space up here. So we know with a geometric sequence, the first thing that you think about, even before you think about your formulas, right, is this small principle that is not on your formula sheet that says R, your constant ratio, is term 2 divided by term 1. Do you understand that? And that should be equal to term 3 divided by term number 2. Okay, so this is the first principle that you think of when you think geometric sequence. Okay, and then you go and think about all of your formulas, but we first have to read to decide if we are going to need those formulas. Okay, then we continue reading. They say the sum of these three terms or three numbers is negative 2x, negative 7, or minus 2x, minus 7. Determine the possible values of x and y. Okay, guys, now a lot of giveaways over here. Okay, now this is the main giveaway. Determine the values of x and y. Remember in math, if you have a starting point, then yes, you're basically halfway there and you won't get 0. Okay, obviously, if your starting point is correct. But this is where they give you a clue of where to start. Okay, so you have to get possible values of x and y. So guys, you have to solve two unknowns. So what do you have to think? You have to think about what we just did in question number 1, which is simultaneous equations. Okay, so you are going to use those principles, simultaneous equations. The only thing is that you are going to have to set up your own equation 1 and equation 2. They give you enough information to be able to do that. So that is what we are going to do. We are going to use simultaneous equation principles, and we are quickly going to set up our own two equations. Okay, so the first sentence, which is the 7x and y, is a geometric sequence. That is what I'm going to use to set up my first equation. Okay, and I'm going to use the principle that I explained to you over here to set up that first equation. So the basic principle of term 2 divided by term 1 equals term 3 divided by term 2 is then going to give me the first equation. So let's go and do that. So R says term 2, guys. Term 2 is x. When we look over here, 7x and y, term 2 is x and term 1 is 7. So we have to go and say, x is term 2 divided by term 1, which is 7. And then we have to equate that to term 3, which is y. And we have to divide that by term 2, which is x. So can you see there we have an equal sign, we have an equation that we can work with, okay? Then I would suggest, since I know that you do not like fractions, let's get rid of these fractions. And how do we do that? When we have one term on the left and one term on the right, and they are both fractions, we can just cross multiply, okay, to get rid of these fractions. So we can go and say that x times x will give me x squared. Okay, then immediately after you have cross multiplied the first numerator and denominator, you write your equal sign, and then you can do your cross multiply the other way around. 7 times y. 7 times y will give me 7y. Okay, so guys, there you have it. There you've written your first equation, and you've gotten rid of your fractions. So there we go. There we call our first. You could have left it a fraction also, but I know how you feel about fractions. So there we go. So then you call this equation number 1. X squared equals 7y. That is equation number 1. Okay. Then you read the next sentence, which says that the sum of the three numbers is negative 2x, negative 7, okay? So the sum of the three numbers, guys, sum means adding up, obviously, okay? So just follow what they tell you. So the sum of the three numbers, so 7 plus x plus y, that is the sum of the three numbers. That should be equal to negative 2x, -7. And they gave you, they told you what this equation should be. Okay. And then you can call this equation 2, but I would first simplify this equation and then call it equation 2. So we know um, you could either get x or you can get y alone on one side. But can you see to be able to use substitution then, right, to solve for x and y? So let's leave y alone on the left-hand side to isolate y so that we can substitute it into equation number 1, okay? So y equals, when we take this plus x over, it becomes negative x. So that means that this negative 2x minus the x coming over is then going to be minus 3x. Okay, so that's going to be minus 3x. And then when we take the 7 over, okay, so when we take the 7 over as well to the other side, that's going to change to negative 7. So that means that this negative 7 already here, and this negative 7 coming over is going to be negative 14. Okay, so negative 14. So can you see now I have made this equation easier as well by adding like terms and isolating one of my unknowns. Okay, so there we go. So now that I have isolated one of my unknowns, y is alone on one side. Now I can say that is equation number 2. Okay, now we can clearly see that we are going to be using, you can use elimination as well. It's up to you, but so we already isolated y in equation number 2. So we are going to use substitution to solve for x and y. So then you're going to tell your teacher that I am going to substitute, okay, equation number 2 into equation number 1. That is what we do with substitution, right? Once we have isolated one of our variables, we substitute the isolated version into the other equation. So let's do that. So we have to substitute y with minus 3x minus 14. So that means that it is x squared equals 7. And then in the place of y in the first equation, we are going to replace it with negative 3x minus 14. Okay, that is what we are going to do. It's as easy as that. All right. Now it's easy. We leave the x squared there, and we are going to sort out these brackets by multiplying or getting the product of this bracket. So 7 times negative 3x is negative 21x. And then 7 times negative 14 is going to be, if you type in your calculator, guys, is going to be negative 98. Okay. Now we can see that uh, this equation has 3 terms. It has 3 terms. 1, 2, 3. One is squared. The other one is an x with its coefficient, and the other one is a constant. That is what we need for a quadratic trinomial. And we can then go and solve x by saying x squared and taking over to the other side the 21x, and it becomes plus 21x, and the 98 becomes plus 98x, and equating it to 0, so that we have our quadratic trinomial to factorize alone on the left-hand side of the equal sign. So now we can go and write our factorization brackets, because that is what we do when we factorize a quadratic trinomial. So x times x will give me x squared. And then we can see that our signs is in my trinomial is a plus and a plus. So that then means it's going to be a plus and a plus in my brackets as well. And then we have to ask ourselves, what times what gives me 98, of which when I add these numbers together, it would give me 21 as well, because the signs are the same. You can think of it like that. Okay, so what times what will give me 98, guys? We saw over here 7 times 14 gives me 98. And when we add 7 and 14, it also gives me 21, right? So then that means we can use 7 and 14. Now, let me just tell you something, guys. For those of you who aren't mathematically inclined, as I explained in question number 1, these are quite big numbers, 98, for instance, okay? And if you missed going back to the previous step to see that 7 times 14 gives you 98, then you would have wasted time in the test to see what factors of 98 would give me the answer of my middle term of 21x. So, guys, what you do then is then when you want to factorize a quadratic trinomial, you can use your quadratic formula, the one that says x equals minus b plus minus the square root of, guys, we all know that, right? So you can always use that formula when you factorize a quadratic trinomial. So if you know you struggle with the factorization by yourself, then you can go and use that formula. I had a few students that weren't mathematically inclined that always just jumped to this formula to get their answers for the factors or the x values of the quadratic trinomial. So please remember that for me, okay, if this is too difficult for you. Okay, so now we can obviously get our x value. So that means that x equals -7. When we equate this bracket to 0 and take the 7 over to the right, we would get x equals -7, and then or x equals -14. So there we have the x values, guys. Now we only need to get the y values, and then to do that, we would say we are going to, guys, you can actually, you can just go and say substitute x equals -7 or x equals -14 into, let's go use the most basic formula, guys, and you want to get the y value, right? So you are going to use the most basic formula, which is this one over here. Okay, this is the most basic formula. Can you see? It has y isolated, and you want to get your y value. So you're always going to use your simplest formula where you can get the value of y the quickest, and therefore you would say you would substitute it into equation number 2. Okay, so let's go ahead and do that. So you would say that y equals -3 times -7. Okay, we are first replacing x with -7 and then -14. Okay, so when you type that into your calculator, you will get your y value of 7. Okay, then on the other hand, if we go and replace x into formula or equation number 2, okay, if we go and replace it with -14, okay, and then -14, you would then get that y value would be equal to 28. Okay, guys, and there you have your answer. Okay, so yes, that was basically the question that was asked of you guys. Now, there is usually exam technique when you answer simultaneous equations. You can go and apply that always, and you can go and draw your little block over here giving us the information, which says that when x equals -7, then y equals 7. And when x equals -14, then y equals 28. Okay, and then that is your final answer for this specific question. And then when we see this and your x and y values are correct, you will get your marks. Okay. Okay, guys, so that was it for question number 2. So as you would see then actually that the only thing that made this 2.5 a bit difficult is that you had to realize that you have to do simultaneous equations. You have to set up your equations yourself, and from there we know how to do simultaneous equations.